All right. Good morning, everybody. Welcome to, well, it's drying out Wednesday morning. I don't know about you, but I got woken up about 3:30, quarter to 4 by a thunderstorm. Uh, and I've been up ever since. But I'm still all excited about today's chemistry lecture. So, good morning. Welcome to another exciting morning of Chem 1105 with your host, me, Dr. White. Lots to do today. So, let's get started. First of all right, thumbs up, people. Do you see test number 4 information on your screen? Thank you. All right, let's go through this. You were sent this as an email and it's in the announcement of Blackboard on Monday. Because this semester started on a Tuesday, I changed things a little differently now, this part of the semester. And on this Monday coming up next week, I will be giving test number 4 during our Zoom meeting time, just like I did 1, 2, and 3. However, before we won't have a lab, we'll have a lecture for about an hour. And you will download the password. I'll send you, uh, you'll be downloading a password protected test number 4, which I should make available by this Thursday. On Monday at 10 a.m., I'll say Gain Gesund, let you go, and then I'll send out the email with the password for your version. Yes, there'll be 2 versions of test number 4 PDF file. You'll have until 11:30 to finish test number 4 and upload your test number 4 answers to Blackboard. It should take usually test number 4 when I do a test face to face about 40 minutes. I'm giving you a lot more time. Now, test number 4 will cover acids, bases, chapter 7, and organic chemistry, which I'll finish up today. Test number 4 has 17 problems on 9 pages. Relax. You know how, if you can do the practice problems, you can do test number 4 quite well. It has no multiple choice questions, but some questions are multiple part. And it will have 56 points on acids and bases, chapter 7, and 49 points on organic. And if you notice, it adds up to 105. Yes, there's five bonus points on test number 4. And this Thursday, meaning tomorrow, I will do a review of test number 4 material. And just to let you know, we will have our regular Zoom meeting for a lecture on Monday at 9, and then at 10 o'clock, you'll take test number 4. Any questions about test number 4? Let's see. Yep, I got my speaker on. Early on when I started doing Zoom, I have powered speakers up here. They're about this big. That's why I don't have my hearing aids on. And I forget to turn them on. Some say, Jada, the review for test number 4 will be tomorrow, right before our lab. And test number 4 will be this coming Monday. You should have gotten an email, and it's also announced in Blackboard, which you can go and look at. Also, if you look at my syllabus, I believe that's in there. All right, that's one thing. What can I say except, sorry, I made a big mistake for the lab you did yesterday, and I had it shut off right when it was time to shut off, so you couldn't see it. And I picked the wrong date. That rarely happens, but it did. That's been corrected. So you should be able to see and download the lab for unknown acids that's due tomorrow. All right, speaking about labs, make sure you turn your labs. It's getting to the end of the semester and you're not going to have extended time to hand them in. And if you don't, you lose 10, possible 10 points. That's never going to be good for your grade. So please hand in labs. All right. Another one I want to tell you about, I believe it's next Monday, is the deadline for the extra credit project. And I'd highly recommend that you email me your extra credit project before you turn it in, and I'll check it and tell you this is right, this is wrong. That way, there's no reason if you do it, you shouldn't be able to get 10 points. And it's like getting 10 more points on any test, but you got to do it right. And I'm offering that public service from me, Dr. White, that I will check it, your project, before you hand it in and help you correct it. So if you make any effort, it doesn't take that long to do it. All you got to do is go into your bathroom or your kitchen or both and look at some labels and pick out some molecules. If you don't want to do that, just go out in any big box store or supermarket and go down to personal care aisle and pick up things. If you don't want to look at it right there, with your cell phone, take pictures of the label and look at them when you get home. But again, so you can get your 10 points, be sure to email me your project before you upload it to Blackboard, and I'll help you correct it so you do get 10 points. All right. Any questions about any of those topics? Well, let's get to work. And I sort of sped through it, but I'm going to do a little quick, let's do it again, which I haven't done this semester. When we talk about organic chemistry, the first thing you should know is the carbon atom. Organic molecules, all of them have carbon and hydrogen. If they don't have that, then they're probably inorganic. And because carbon has 4 valence electrons, it can bond to other elements, including itself. And the important thing is, you should know there's always 4 bonds to carbon or carbon atom. And you should know this. Oh, I should be subtle. You should know there's always 4 bonds to carbon. Now, when we talk about organic chemistry, a good starting point are with the hydrocarbons. And hydrocarbons are molecules with only carbon and hydrogen atoms. And you should know this. Hint, I'm not going to write on the screen, but I hope you get the message. When we talk about hydrocarbons, there's 2 types of hydrocarbons. And you should know this. One type is a saturated hydrocarbon. And that's molecule, since it's a hydrocarbon, it has only carbon and hydrogen atoms. And because it's a saturated hydrocarbon, it's a molecule with only carbon and hydrogen atoms, which all carbon-carbon bonds are single bonds, 1 pair of electrons. And we show that like this in organic chemistry. We don't show the valence electrons using Lewis structures. Usually we use a line for a pair of electrons. Now, the other type of hydrocarbon is an unsaturated. And the un means molecules in the hydrocarbon with only carbon hydrogen atoms, but now that contain at least one or more carbon-carbon multiple bonds, which we call double or triple bonds. And it would look like this: a double bond, a triple bond. And that's an unsaturated. Where the term saturated and unsaturated means you can add more hydrogens to double and triple bond. It's unsaturated. Saturated, you can't add any more hydrogen atoms. Now, I talked about functional groups. I'm not going to ask you what is a functional group, but it's a specific group of atoms in a molecule and they undergo the same type of chemical reactions. No matter what type of molecule the functional group is in, that's the type of uh, chemistry they undergo. Just like my door right there, you know what a door does, or I don't know if you can see it, my office chair. This is a good one. For those of you who want really high-end, reasonably priced office furniture, there's a place called Rework Furniture in Oak Park. They deliver, and they have used high-end quality office furniture. The chair I have, I think it's called a steel case, I forgot what, normally lists at $800, yeah, for the chair. And I paid $350 for a used one that looks brand new. It's been refurbished, but it looks and feels brand new. That's a heck of a savings. And I really like it. It's built like a tank. It weighs about almost 150 pounds. Yeah, it's built like a tank, but it's comfortable. All right, now there are different functional groups, which I didn't ask you to learn, but let me show you because I skimmed past this when I did it before. Double bond, this is in a molecule. Triple bond, this is alcohol, carbon with a hydroxyl group on it. Aldehyde looks like this. And these are all molecules in our daily life. Ketone looks like this. The letter R is used like X and Y to mean something with carbons and hydrogens. Now, carboxylic acid looks like this. And carboxylic acid is responsible for vinegar. When R is CH3, it's called acetic acid, that's in vinegar. And also carboxylic acids are used to make many things in our daily life. I worked for a company that made carboxylic acids. And carboxylate anions, this is one type, where M can be equal to sodium, potassium, or lithium, is used for many things. Esters, and you don't have to write this down, Dr. Weiss is having some fun, are responsible for the smell and taste of fruits and vegetables and most flowers. Next time you smell a rose, and Dr. White likes smelling roses and other flowers, what are you smelling? An ester. Next time you taste and smell a banana, and I don't like bananas, but still, I know how to make the ester that makes a banana smell and taste like it does. That's organic chemistry. And perfumes are very complex mixtures of esters. And amines are important. Quaternary ammonium salts are used as fabric softeners and antimicrobial compound, and amides are also important. I got a question for all of you. Let me go to this view so I can see everybody. How many of you have ever heard the term protein? Give me a thumbs up. Proteins are amino acids held together. Now, if you're a protein chemist, you call that a peptide bond. But the real functional group, that's really what it is called for synthetic organic chemists, is an amide bond. And your skin is held together. The amino acids in your skin and your hair are amides. Oh, that reminds me of something. I'll tell that story later. All right. Now, functional group reactions, it's a reaction of a certain functional group to yield the same type of product most of the time. There are exceptions, but that's the beauty of organic chemistry, and it is beautiful. Well, I'm biased. I'm an organic chemist. Now, how do you find a functional group in a molecule? You look for anything that is not a, oh, excuse me, getting choked up over this exciting stuff. You look for anything that is not a carbon atom, hydrogen atom, or carbon-carbon single bond. So when you look at an organic molecule, you look for anything that's not carbon, hydrogen, or a carbon-carbon single bond, and that's going to be a functional group because that's where all the fun happens in a molecule. And let's have some fun. Whoa, hold on. Or maybe 3. And there's something for you to have fun with. It's a 2-for-1 sale on Wednesday, the 28th. Wow, where's this year going? Where does summer go? All right, your turn. Circle the functional groups in the following molecules, 2 or 3 points each. And when you're done, don't forget, give me a thumbs up. And remember, look for something different. What's not carbon, letter C. What's not hydrogen, letter H. And what's not a carbon-carbon single bond, one line between carbons, should get your attention like that, or better yet, like that. Newsflash, newsflash. Later today, I'm going to have a special surprise for you. You're going to love it. I hope so. So stick around and you're going to be in for a big surprise. You'll like it. Oh, wrong poll. Right poll. It's one of the bad things about teaching on Zoom when the students don't turn on their webcams is I can't tell when people are done. Face to face, you can. It's easy. All right, let's get to work. And the question is, circle the functional groups in the molecule. And how do you do that? You look for what's not a carbon-carbon single bond. If you see two or more lines between carbons, that's a double or triple bond. That, like here, this is a functional group. You look for what's not carbon or hydrogen. Oxygen with a hydrogen and a carbon, we call it an alcohol, but you just at this point, it's a functional group, something different. And finally, this carbon here, double bond to this oxygen, oxygen here and here, and this is a functional group. It's called an ester. Now, if we look in B, ooh, a nitrogen, that's different from C and H, and this is called an amine. Ooh, a triple bond, and that's different. And finally, ooh, carbon double bond to oxygen. It's got carbons here and here. This is called a ketone, but you don't have to know the names, but you should know how to circle. And if your circle's a little off, all right, one of your colleagues asked, how do you determine a functional group? Good question. And let's go back. You look for anything that's not a carbon atom, the letter C, or a hydrogen atom, the letter H, or a carbon-carbon single bond, one line between two carbons. You see two or three lines, carbon to another letter, that also will be a functional group. And you're welcome. Remember, I said it the first day, I'll say it now, I'll say it after the class is done, I'll always say it. In my universe, my world, there's no such thing as a dumb question. That goes through when I'm teaching, like now, that goes if you saw me, ran into me on the street or in a supermarket, I'll always, if I can, somebody asks me a question, I'll try and do that. Oh, on that, Lily, I'm not teaching the actual functional groups, but some functional groups are defined as just two atoms bond together. Sometimes you can have functional groups that have more than two atoms in it, and that's why. Go talk to Mother Nature about that. No, I'm just kidding. You're welcome. Again, ask questions. That's why you're here, to learn. And it's fun. I hope it is for you. Oh, let's do another one of these. All right, I think I threw in everything but the kitchen sink in this one. Circle the functional groups. Have fun. Remember, look for what's different. What's not a C carbon, H hydrogen, or carbon-carbon single bond, one line to carbon, is a functional group. And remember, in a ring, every bend in a line is a carbon. I'll give you another 20 seconds starting now. Time's up. Let's do it. Circle the functional groups. How do you do that? You look for what's different, what's not carbon, what's not hydrogen. Ooh, nitrogen, and that's an amine, but you don't have to know it. Ooh, oxygen to carbon. Remember, every bend in a line is a carbon here. And this is called a ketone. Ooh, oxygen here with a hydrogen to carbon. That's called an alcohol. Ooh, double bond. That's right there. Ooh, an oxygen, double bond to carbon. We call that an aldehyde. Now, you don't have to know the names, but you should be able to circle functional groups. Now, we went through how to draw organic molecules, how to do condensed structure. Remember, there's 4 bonds to carbon. I didn't really expect you to learn and won't ask you to learn about using parentheses, but tomorrow's lab, I'll talk more about it because we use it then. And I showed you cycloalkanes are represented by polygons, and each bend in a line is a carbon. Now, I don't do it when I teach to this level or general chemistry first semester, where you can use the line method for carbons not in a ring, and there every end of the line is a carbon, every intersection is a carbon. Hydrogens are not shown. So what does that mean? What do you need to know how to do? I'm so used to drawing structures with hydrogens, I've got to think about it, not drawing them in. All right, I'll do the first one. How do you know how to draw in hydrogens? How many to put? There's 4 bonds to carbon, always. And now, organic chemistry time, high level math. How many bonds to this carbon? Count the lines. 1. Should be 4 bonds to carbon. 4 minus 1, high level math. Hopefully you all got 3, and it should have 3 hydrogens. This carbon, 1 line, 2 lines. How many bonds do you see? 2. But there should be always 4 bonds to carbon. Therefore, 4 minus 2 equals 2. So that has 2 hydrogens. Now this carbon right here has 1, 2 again, 2 bonds, but there's always 4 bonds. 4 minus 2 is 2. And this last carbon right here has 1 line or 1 bond, and there should always be 4 bonds to carbon. 4 minus 1 is 3, so I write my 3 hydrogens. And that's how you do it. I'm so used to automatically putting in hydrogens, I have to hold my hand so it doesn't do that. All right, your turn. Put in the hydrogen atoms in this molecule. 3 points each. And give me a thumbs up when you're done. Oh yeah, I forgot. This is the semester. I don't want to do thumbs up class. I'll give you another 25 seconds to finish, so please finish. All right, let's do this. How do you know how many hydrogens to put in? Because you know there's always 4 bonds to carbon. If we were in a classroom, I'd be doing this. How many bonds to carbon? 4. Does it look like it's coming right at you? 4. I can do it backwards too, my hand. I'm ambidextrous. 4, 4, 4 bonds to carbon. Yes. 1, 2, 3, 4, 4. So now we look at the first carbon. There's 1 line to it. That means 1 bond, but there should be 4, and the remainder, 3, are always hydrogens. Same thing to this carbon. 1 bond, 4 minus 1 is 3 hydrogens. Now this bond has, carbon has 1, 2, 3. And there's always 4 bonds to carbon. And if there aren't, the remainder are hydrogen. Well, 4 minus 3 is 1. So there's 1 hydrogen there. This carbon has 2 bonds to it. Count the lines. 4 minus 2 is 2. Same thing here. And this carbon right here has 1 line or bond. 4 minus 1 equals 3. And that's how you do. Oh, let's do another one. These are a lot of fun. Ooh, that's going to be a lot of fun. So put in the hydrogens for that molecule. Remember, count the lines, and carbon always has 4 bonds. Always. And I'll wait and be patient while everybody finishes. Finish. All right, let's do this. Remember, there are always 4 bonds to carbon. And if we look at this carbon, there's 1 bond, 4 minus 1 is 3. And you make up the last 3 by putting hydrogens. Same thing here and here. 1 bond, 4 minus 1 is 3. Now, if we look at this carbon, it has 1, 2, 3, 4. 4 minus 4 is 0. I don't have to put any hydrogens in. Now, this carbon has 1 bond to it, so 4 minus 1 is 3. Now, this carbon has 1, 2, 3 bonds to it. 4 minus 3 is 1. Ooh, now we got some fancy carbons. This one has 1 here, but notice right here, there are 2 bonds, 2 lines, 2 bonds. So total 2 plus 1 is 3, should be 4, 4 minus 3, 1 hydrogen. Same thing with this one. 3 lines, 2 here, plus 1 here, and that makes it 3, 4 minus 3 is 1. Now this carbon has 2 bonds, so 4 minus 2 is 2. Now, let's look at some really exciting carbons. Now you know I'm an organic chemist. And this one right here, how many lines does it have? 1 plus 3, we call those bonds. So there's already 4 bonds. 4 minus 4 is 0. Needs no hydrogens. And the last one, notice there are 3 bonds right here. 4 minus 3, 1. And that's how you do it. Remember, there are 4 bonds to carbon. All right, another important skill you should have is how many carbon atoms are in or in the following molecule. You count the carbons, letter C. 1, 2, 3, 4. So the answer is 4. Ooh, what do I do here? There are no letter C's. What do I do? Well, this is a ring, and every bend in a line is a carbon. 1, 2, 3, 4, 5. So that would have 5 bends or 5 sides, 5 carbons. And that's how you count how many carbon atoms are in a molecule. So, your turn. And for C, D, and E, how many carbon atoms are in each molecule? 3 points each. And let's try this once more. When you're done, give me a thumbs up. Thank you, Sean. And thank you, Rain. All right, let's get going because it's just about break time. And the question is, how many carbon atoms are in the following? And what you do is count carbon C's. 1, 2, 3, 4, 5, and this is 6. So the answer here is 6. Oh no, no C's. Every bend in a line is a carbon. 1, 2, 3, 4, 5, 6. So that would have 6 carbons. Ooh, let's look at this one. Well, we've got 1, 2, 3 there, but now this ring has 1, 2, 3, 4, 5. So 5 plus 3 equals 8. And that's how you count carbons in a molecule, which is sometimes important. And it's time for Dr. White to take a break and do some stretching. Otherwise, yesterday I was sitting too long. All of a sudden, I started getting leg cramps. That was not fun. But I'll see you in 5. Come back at 9:50. let's try that again. Let's get going. Now, when we talk about organic chemistry, we have what's called general reactions. When you have a certain type of functional group or molecule, you always get the same type of products. And I'm only going to show you two reactions. I should tell you these general reactions, when I teach or one semester organic, I usually teach about 55 general reactions. I personally know a couple hundred, like about 400. There are more, but the one areas I work in, I know them quite well. That's about 400. And I'm only going to teach you two, but they're important ones in your daily life. So let's take a look at the first one. Whenever you have a saturated hydrocarbon, that's a molecule with only carbon hydrogen atoms and carbon-carbon single bonds. Turns out it's wider than this, but for this class, I'm limiting it to this. And you react it with oxygen, you always get carbon dioxide, water, plus heat. So what does that mean? And let's look at the following. I will ask, because I haven't asked in a while. Thumbs up, people. Do you see on my whiteboard? Give the product or products. When you put it in bracket, that means thank you, Sean. Well, what is this? Well, it's only one carbon and four hydrogen. This is the simplest saturated hydrocarbon, I'll abbreviate, and we call methane. You also know it as natural gas. And that's what you cook with, you heat your house with, you heat your your water with, your hot water heater here. And if you react it with oxygen, the products, chemical products, carbon dioxide and water. Remember, in organic chemistry, we're lazy. So if we don't have to, we don't balance chemical equations. So the answer here is CO2 plus water. And that's what you write down. Oh, let's do another one. And then I'll let you have some fun too. And the question is, give the product or products for the following, 3 points each. And you look at the molecule and notice there's only carbon, hydrogen, and carbon-carbon single bonds. And that means this is a saturated hydrocarbon. And we're reacting with the oxygen. And the general reaction you have memorized, hint, hint, gives CO2 plus water. Therefore, this is a saturated hydrocarbon. This is oxygen. I'm going to get carbon dioxide plus water. And that's the beauty of functional group chemistry. You helps you predict what you're going to get. And I would ask you, If you react this molecule with oxygen, what do you get? Your turn. And don't forget, when you're done, give me a thumbs up. Oh, wait, I forgot. This is the I don't want to do thumbs up class. How about trying it just for me, please? All right, let's do it. If we look at this molecule right here, what do you see? Carbon, hydrogens, and only carbon-carbon single bonds, like right here. And that's the saturated hydrocarbon. And if I react that with oxygen, my general reaction, think of it as a roadmap telling you where you're going to go to, goes to CO2 plus water. And therefore, my answer is CO2 plus water. Oh, let's do one more. And there you go. If you react that molecule with oxygen, what do you get? By the way, organic chemists are powerful. We can bend arrows. Oh, that was lame. Actually, we do. When you're running out of space, instead of a straight arrow, you bend it. All right, let's try this. What do we see in this molecule? Only carbon, hydrogens, and carbon-carbon single bond, which means it's a saturated hydrocarbon. What are we reacting it with? Oxygen. And I see a question or comment, so I better get to work. One of your colleagues asked, is this going to be on test number 4? And the answer is yes. If you look at the announcement I read earlier, there's, I think, 49 points on organic, and this is the type of questions. Look at the problem set, which I will do tomorrow, and you'll see there are problems doing this. And the answer is when you react the saturated hydrocarbon with oxygen, you should know you get CO2 plus water. And the answer here is CO2 plus water. Now it's time for a big pro tip from me, Dr. White. But first, water. And the question is, what's the best way to effectively memorize organic reactions, the general ones? And some people have flashcards. They never work that well, at least from my personal experience and most of the students I've taught organic chemistry. And also when I've taught this in 1105. How do you do it? You write the general reaction down 5 times and say it. And then do it a second time and it burns it in your brain really good. What do I mean by that? I've been doing it to you secretly, but to memorize it, you would get somewhere where you can either say it out loud or silently in your mind. Saturated hydrocarbon plus oxygen gives CO2 plus water. And you have to both say it and write it. Then you do it again. Saturated hydrocarbon plus oxygen gives CO2 plus water. Then you do it again, again, and again. And next time you do 5 more like that again, and it works quite effectively. All right, now another reaction I'd like you to learn is called hydrogenation. That's when you add hydrogen gas to an alkene. An alkene is a carbon, and I won't ask you that. Hold on, there's a piece of dust on my tablet. Is a carbon-carbon double bond. And you need a catalyst like platinum, palladium, or nickel. A catalyst is something you add that makes a reaction go quicker. Reactions take time. There can be fast ones and slow ones. And a catalyst makes the slow ones go quick. And here I have R, which means anything with carbons, but in reality, a simpler way is have a carbon-carbon double bond in a molecule reacted with hydrogen and a catalyst. And the catalyst can be either platinum, palladium, or nickel. In industry, we use nickel because it's cheaper than platinum or palladium. And you break one of the double bonds. It's called a pi bond. That I'll never ask on a class, but I'll say it without even thinking. And you break the pi bond, each carbon to the double bond gets a hydrogen. This is called hydrogenation. And we use it a lot in the chemical industry. I have personally. Again, I'll rewrite the question. When I say give, that means really draw or write. All right, everybody see the whiteboard up there where I have give the product or products for? Thank you, Sean, again. You got the fastest thumb on the class today. Thank you. All right, and you too, Rain. Thank you. All right, now you look at this molecule. Look for what's different. Ooh, what's not a carbon-carbon single bond? Ah, double bond. Immediately all I see is this. And I see, oh, I'm reacting with hydrogen and nickel is a catalyst. Remember, the catalyst can be nickel, platinum, or palladium. And guess what? You break one of the bonds, each carbon gets a hydrogen. Now, this is an important thing. Do you break carbon-carbon single bonds? No, except for combustion. When you burn something, you don't. It's rare. In this class and other classes I teach, you don't. So don't. So I have 4 carbons here. I'm going to end up with 4 carbons. These 2 carbons are of the double bond, so each one gets a hydrogen. Notice I broke the bond, because if I didn't, there'd be more than 4 bonds of carbon. That won't happen. And now I fill in the rest of the carbons. Hold on, I want you to see me. Everybody see me in the corner? There's 4 bonds to carbon. So I know how many hydrogens to put in. And that's the answer. Now you could have said, well, here's a hydrogen, here's a hydrogen. I can make that CH2, same thing here, 2 plus 1, CH3. I would recommend you write this because that's one less step you have to do. All right, time for you to have some fun. And now have some fun. What would be the product or products for the following reaction? Really, in this case, it would be, well, product. And give me a thumbs up when you're, oh, wait, this is a class that doesn't like using thumbs up, so I better use the poll. All right, let's do this one. And the first thing is look at a molecule and look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, one line between carbons is something different. Oh, look. a double bond. Everything else, carbon-carbon single bonds, and double bond reacting with hydrogen. What's nickel? A catalyst. Remember, the catalyst can be nickel, platinum, or palladium. And you break one of the bonds called a pi bond, but I won't ask that. And each carbon of the double bond gets a hydrogen and loses one line between that. Now, do you break carbon-carbon single bonds? No. So you have 1, 2, 3, 4, 5 across. 1, 2, 3, 4, 5 across. And on this carbon, you have this CH3. Here are my 2 carbons of the double bond. I've lost one of the lines or bonds because I'm hydrogenating. And each carbon of those 2 carbons gets a hydrogen. And now I can fill in the rest of the hydrogens because I know there's 4 bonds to carbon. And that's how you do. Oh, let's do one more. Your turn. Give the product or products for a following reaction. 3 points each. All right. I'll do another one after this. Now, are some of you, I'm going to do, I'm going to stop the polling. And if you're having trouble, and I don't know who says yes or no, it's anonymous, but are you confused by this reaction, this type of problem? Put yes. If not, put no. I'm just curious. And this is new stuff. Again, not are you done, but if you're confused, put down yes. All right, let me do this one. We'll do one more. And to the colleague who asked me to do another one, because some of you are confused, thank you. All right, let's do this one. You look at the molecule, look for what's different. What's not a carbon-carbon single bond or carbon-hydrogen double bond. This is reacting with hydrogen, and what's platinum? It's a catalyst. Remember, the catalysts are nickel, platinum, or palladium. And you break one of the bonds, and each atom of the double bond, each carbon, gets a hydrogen. And you make a new molecule. And that's what you're trying to do. So, do you break carbon-carbon single bonds? No. There's 3 carbons here. But the second bond, which is called the pi bond, you break easily. Now, the question someone asks is, how do we determine which one to attach the hydrogen to? And the answer is each carbon of the double bond that no longer is the double bond. These two, you break one of the bonds. That's what this tells you. Go from here to here, 2 lines, bonds to 1 bond. And each of those carbons that were in the double bond gets a hydrogen. So each of these 2 carbons gets a hydrogen. And you fill in the rest of the hydrogens. And that's how you do it. I'm glad you see now. Let's do another one. And this is the beauty of functional group chemistry, because even though these are different molecules, they undergo the same type of chemical change or reaction. Did I make a mistake? Once in a while I do. Let's see if I did. Now, one of your colleagues asked, should it be something else? And there are 2 ways of writing this. The one I just did. 1 hydrogen plus 2 is 3. 1 plus 1 is 2. And this one's still the same. Now, since I'm the one grading it, these are equivalent and you can do either one. I prefer students to do this way because it's one less thing you have to do in your brain on the test. And that's why. You're welcome. And you're new at this, so it's difficult, but don't forget, I've been doing this a few more weeks than you have. Many, many weeks more. Years. I hate to say this, decades. Oh no, I'm going to scare Dr. White. It's time for me to scare myself. I've been doing it before all of you have been born. Oi. Either I'm that old or you're that young. Oh, it's totally Be Silly Wednesday, and I am. All right, let's do this. What's different? Look for what's not a carbon-carbon single bond or carbon hydrogen. For this class, look for what's not a carbon-carbon single bond and a double bond. And as soon as I see that, this is all I think about. I'm reacting that double bond, that functional group, with hydrogen. Nickel is a catalyst. Remember, the catalysts equal nickel, platinum, or palladium. And you memorize, you break one of the bonds. It's called a pi bond. It's easy to break. And each carbon of the double bond gets a hydrogen. Now, you break carbon-carbon single bonds. Don't forget, double bond has a single called a sigma bond plus a pi bond, and that sigma you don't break, the other one you did. So I have 1, 2, 3, 4 carbons. I'm going to end up with 4 carbons. Which carbons? Oh, I'm going to go Technicolor on you. Which carbons were the carbons of the double bond, this molecule? These two. Which are these two. And in your general reaction, the 2 carbons, each of those of the double bond gets a hydrogen. So I'm going to do that. And now I know there are 4 bonds to carbon. So one line, 4 minus 1, 3. This already has 3, so I'll have 1 more. Same thing here. And this will be that. And that's how you do it. All right, we've got to move on because I want to finish everything today. And I also wanted to go back and review like I did, which I think will help you. All right, I talked about different things, switches off, fats and oils, carbohydrates, proteins, polymers, steroids. Those are all organic molecules. Next time you have a potato chip or French fry, that's organic chemistry. Next time you have, for those who are vegans, well, tofu, or for those who are not, hot dog or hamburger, you're eating proteins and fats and oils. That's organic chemistry. And switch is totally off on this slide. Same thing here. I talked about fats and oils yesterday. I'm not going to ask you, but you might want to know. A fat is called a triglyceride. It's a solid or semi-solid at room temperature. Oil is a liquid triglyceride at room temperature. And I talked about different types of fats and oils. That won't be on the test. I talked yesterday about how I just wanted to illustrate when you eat the different food groups, fats and oils, carbohydrates, or proteins in your stomach, there's acid. H plus is the organic way of any acid. In your stomach, it's HCl, hydrochloric acid. If you've been drinking water, like my doctor always reminds me, how you should drink a lot of water during the day. There's water in your stomach, and those undergo a chemical reaction to break it down to other molecules that your body uses for various things. All right. There are a couple of things I would like you to leave this class knowing. One important thing I've already told you, pH and the pH scale, 0 to 14, 7 neutral. The other thing is, it's time for you to learn how you get your hands clean. Mine are. How do you get your hands clean? How does soap work? This is one of the things I'd want you to know leaving my class. So let's find out. Now, it turns out there are special types of chemicals, organic chemicals, called surface active agents. And surface active agents, organic chemists are lazy, so we just shortened it to surfactants. And these are molecules that interact at different surfaces, like between dirt in your hand, those surfaces, between dirt and water and your hand interacts, and what interacts is called the surface surfactant. And soap is a surfactant. There are many different types of surfactants. Now, soap has what's called the hydrocarbon tail, and which is lipophilic, and a polar head. Now, I'm going to show you how to remember this in a second. Remember, like dissolves like. Ooh, I even wrote it on here. Know this. Let's take a look at the following. Let's go to the whiteboard. But first, it's time for Dr. White to be subtle. Know this, big time. Thumbs up, people. Do you see the whiteboard now? How soap works? Thank you. All right. First thing you should know, what is soap? And you should be able to draw this. Soap has a long nonpolar tail. These are a lot of carbons and hydrogens, and a polar head. You should know this. And soap has a polar head, nonpolar tail. Whether it's bar soap or the liquid soap in your bathroom or the dishwashing soap you use for your dishes or your laundry, they all have this, not the same exact molecule, but it's all nonpolar tail, polar head. Now, you learned before, water is the most polar substance on our planet. Dirt and grease, but I'll just talk about dirt, is nonpolar. And the whole key to the puzzle, how does soap work, is, and so important, I'm going to write it in big fonts like dissolves like. And as I taught you earlier, polar things are soluble in polar things, nonpolar things are soluble in nonpolar things. Try and mix two together, they're not. So you can't wash your dirt off easily with water because like dissolves like. One's polar, one's nonpolar. But let's say you got dirt on your hands and you use soap and water and you go like this. What's happening on your hand to get the dirt off? Worked on mine. And let me explain, you should know this. Let's have a piece of dirt, little, that I magnified a lot. Now, if you use water, water looks at this and says, dirt, you're nonpolar, I'm polar. I know like dissolves like. I want no part of you. Stay on your hand. But if you use soap and water, the nonpolar tails of the soap is attracted to the dirt, but the polar heads want to be as far away. And this totally surrounds this. When this happens, dirt surrounded by soap molecules this way, this is called a micelle. And you should know the structure of a micelle. I'll repeat that. You should know how to draw a micelle. Now, my cell has the polar heads totally surrounding the dirt, and it looks like this. Well, a representation. Whoops, wrong thing. Right thing. Everybody see the blue spheres on your screen now? Blue balls. Oh, come on, people. All right, thank you, Sean. Now, these are my cells. What they did is they cut out a part right there so you could see inside, but really that part where the segments cut looks just like this right here. And now you can see for each soap molecule, the nonpolar tail, and the outside is the polar head. So these spherical shapes called micelles. Now when water looks at that, it only sees the polar heads. And water says to a micelle now, water looks at this and says, oh, micelle, I'm polar, you're polar, let's go down the drain together. And they do. And now your hand's nice and clean. Let me go through this. You should know how to describe how does soap work. And I would also put down, be sure to include the structure of soap and talk about micelles. And now let's do that again. Windows Defender just told me my computer's healthy. Thank you. But anyways, how does soap work? You should know that soap has a nonpolar tail and a polar head. And if you have bar soap, is 16 CH2 or 16 carbons here and a polar anionic head here with a cation. And soap, nonpolar tail, polar head. You should know water is polar, dirt is nonpolar. The most important thing, how does soap work, is like dissolves like. That's the whole piece of the puzzle. And when you know that, and the structure of soap, when you use soap, the nonpolar tails are attracted to the dirt. The polar heads, where the circle is, wants to stay far away. And what you call this new structure is a micelle. And a micelle now looks polar to water. And water sees a micelle and says, oh, micelle, I'm polar, you're polar, let's go down the drain together. And they do. And that's how you get your hands clean. And this morning when I was taking my shower, I was thinking, oh, I'm probably the only one in the Northwest suburbs right now who's thinking, I'm making micelles. And that's how I got the dirt. And now I'm squeaky clean. Can you hear squeak, squeak? No. But anyways, really, that's how you get your clothes clean, your skin clean, your hair clean. And if you wash your car, you're good making micelles too. Now, an interesting thing that a couple years ago, an organic chemistry student asked me about was a product that was just coming out and had rave reviews. How many see bottles on your screen of micellar cleansing or micellar cleansing water? Guess what? First of all, I've been told I don't use them, but a number of students have told me it works very well. It's a good product. But guess what? There are no micelles in those products. There's soaps and other chemicals that help the soap work better. And once you use it, then you make micelles. But in the product you buy in the bottle, there are no micelles. And I always find that exciting and interesting. But you didn't think we'd get into how you get your hands clean in this class. We did. You should know about soap. And know it. There are a couple of things, 2 or 3 things I'd like you to leave my class knowing. One, I think is very important, is pH. The other is how soap works. And I'll go through this again tomorrow. All right, if I look at the clock, well, let's do this one more time, talk about soap. Remember, soap, how does it work? You have a soap molecule, nonpolar tail, polar head. Dirt is polar. Dirt is nonpolar. Water is polar. Dirt is nonpolar. The most important thing you should know, like dissolves like, explains how soap works. And if we take a dirt particle and magnify it, when you wash your hands with water and soap, nonpolar tail of soap wants to get near dirt because the like dissolves like. The polar head wants to be as far away because the like dissolves like. And this is called a micelle, what you make. And a micelle is the dirt particles surrounded by soap molecules such that the heads are on the outside. So now water looks at a micelle and says, oh, micelle, you're polar, I'm polar. I know like dissolves like. Let's go down the drain together. And they do. Now, it's time for a break. I'm going to give you a whole extra minute. Come back at 10:50. Got a whole extra minute. Thank you, Dr. White. You're welcome. I'll see you at 10:50. Love that whistle. Time to get back to work. All right, now, there are a couple of things I'd like you to learn leaving my class. One of them I just taught you was how does soap work? The other one is how does this magic device called a towel, this is actually a microfiber one, but a towel, ooh, when I go like this, a towel, how does it get your hands clean? It's organic chemistry. Now, what is a towel? It's cotton. If you have a cotton one, just like my shirt, cotton. And how does a towel work? By hydrogen bonding. Uh-oh, come on, hold on. My computer's burping at me. All right, I'm back in business. Sorry about that. When I use my tablet a lot with organic chemistry, it gets upset. All right, how does a towel work? By hydrogen bonding to water. Remember we talked about hydrogen bonding and time to be subtle. Now, when we talk about water, I taught you earlier, water, there's a slight positive charge on hydrogen, slight negative on oxygen. If I have another water molecule, same thing. This means slight or little, and it means little difference. And delta means this is a small case. So here you have a slight negative charge, here you have a slight positive, and they attract, and we call this force a hydrogen bond. Now, here's the structure of cotton. N here is a couple 100,000. And notice it has carbons with OH, we call those hydroxyl groups. And each one of these carbons with an OH, same thing happens. And if I have water, you can have hydrogen bonding between the cotton and, like here, this will hydrogen bond. And that's how you get your hands dry. Cotton will do this. Paper towels will also have similar structure. It's processed differently. That's why cotton feels different than paper towels, because cotton comes from a cotton plant, which has a slightly different structure than paper towels, which come from pulp from trees. But they both hydrogen bond. Now, how many of you have heard when they talk about certain fabrics breathe? Have any of you ever heard that term before? Give me a thumbs up if you've heard fabrics breathe. I see some of you are starting to give me a thumbs up. Oh, I forgot. No, I shouldn't have had a V8. This is I don't want to use my thumbs up class. But anyways, when they talk about fabrics breathing, no, it's not going, it's not breathing that way. What they really mean is it can wick moisture away from your body, otherwise known as hydrogen bonding the water to get it away from your body, which makes you more comfortable. Now, all of you, and I can say this honestly, don't remember a time long ago when the big music, which was awful, I didn't like it, was disco phase in this country, in this world. And prior to going to disco, which I didn't go, I was hard rock and still am. But anyways, did I tell you, I saw Jimi Hendrix play live. Greatest concert I've ever been in. I saw some other famous groups too, Led Zeppelin, and I can keep on. But anyways, disco had nylon, was very fancy nylon shirts, jackets, pants, and they didn't breathe. It was like being in a rubber sweatsuit for a diver or whatever. And when I was in high school, my mother went out and got me some nice shirts, nylon, and I had a suit and pants. And if I put that on there, it was like being in a torture chamber. And when disco was died, thank God, and I finally said, I hate this. My mother said, yeah, I know. I said, I don't think it's fair to put it in Goodwill. Let's just toss it. And he said, yeah, thank God, because it didn't breathe. It couldn't hydrogen bond, and all the moisture stays on your body. Right now, you're emitting moisture from your skin to cool you down, and your cotton helps you breathe, quote unquote, by hydrogen bonding or wicking away the moisture, the same way a towel does. But you didn't think you'd get into learn about towels and paper towels in my class. All right. Again, you should know, how does a towel work? By hydrogen bonding to water. Do you have to draw this? No, but you should know how it works. Now, there's one more thing I'd like to show you, and that's steroids. And click the switches off, but I thought you'd be interested. This is organic chemistry. Steroids, otherwise known as your hormones, they're based on this ring system. And the ring system, each bend in a line is a carbon. Now, this is called a fused ring system, where they're sharing carbons between two rings, A and B and C and D. And notice this is a 6, 6, 6, 5. And that ring system, all your hormones have that. And let me show you, I'm not lying to you, which is a good thing. Oh, come on. All right. Thumbs up, people. Do you see testosterone Wikipedia on your screen? Over here, I'll click on it and make it larger. This, you don't have to write this down, but this is a structure, chemical structure of testosterone. That's a male hormone. And notice you have ring 1A, B, C, and D. There's other stuff, but this is an organic molecule. Let's do another one. All right. All right, thumbs up, people. Do you see estradiol on your screen? Thank you. Let me blow up the structure. Don't write this down, but this is a hormone. Notice it has 4 rings, 6, 6, 6, 6. This is the molecule, the hormone that regulates a woman's menstrual cycle. By the amount a woman has in her blood, in her body, it controls the menstrual cycle. How it does that, I have no idea. I'm an organic chemist. I know the molecule. And turns out by making a similar one cheaply, organic chemists were able to help develop birth control pills. So organic chemistry has an important role. Again, switches off, but I thought I'd talk about this. All right. Let's go back to my slides because I better show you something. That's not my slides. The end. We've reached the end of this chapter. So you know what that means? It means special show and tell from Dr. White. And I'm going to cut this out of the video. So if you're here today, you're going to see it. If you're not, well, stop by my office hours. I'll show it to you then. I'm going to venture, most of you are very little, or maybe not even born, probably were, but very little, back in 2005. How many remember 2005? And all right, and I'll stick after class today if anybody wants to talk to me. But anyways, back in 2005, I think it was give or take a year, in the United States and down Louisiana, New Orleans, and the area around there, and the states bordering Louisiana, we had a horrific hurricane hit the right dead center. And that was called Hurricane Katrina. And it was devastating. I don't know how many people died, but many people, their homes, apartment buildings, condos were destroyed. And the government had a problem. How do we house these people? So FEMA, the agency in charge there, was unfortunately headed up at that time under President George Bush by an idiot, I'll be honest. But they went out and bought a couple, 150,000 trailers real quick. Well, after a while, people were getting sick living in those trailers, having serious medical issues, both young, old, and their pets. Pets were dying. And there was a very brave woman who I got to know, Becky Gillette, who was at that time with the Sierra Club, but with her own money, she investigated. You know something? I've never asked Becky how she decided to look into something, but she did. And what they found was those trailers were emitting a very dangerous organic chemical called formaldehyde. Switches off on here, but it's something you should learn. And formaldehyde, and I'm an expert in formaldehyde, when used safely and properly, is an important chemical. That plant I just showed you, we used formaldehyde, and that company was the largest, and I think they still are, producer of formaldehyde in the United States, if not the world. Well, formaldehyde, when it's given off, is called free formaldehyde, and you inhale it, is very dangerous to you. You can get cancer, other things that could even kill you. Well, Becky found out, and I'll explain how, that those trailers were emitting a lot of formaldehyde. Well, President Bush and FEMA Director Brown, Bush called him Brownie, that's how I can still remember his name, who was an idiot. But anyways, said no, and they fought Becky. And finally, they had the EPA test it, and the EPA found out Becky was correct. About this time, I heard about it in the news, and I said, I didn't say but I've been raised by my parents to be socially responsible. And at that point, and even now, I'm a socially responsible organic chemist. I'm a world authority in formaldehyde. So I was able to find Becky's phone number. I called her and said, I do consulting. I know formaldehyde quite well. I work for a formaldehyde producer, the largest one in the United States. Any way I can help you, I will. And I did. And one of the things she asked me to do, which I did, I wrote a letter to the, what they call it, administrator of the EPA, head of the EPA, and also the new president, President Obama, explaining how these new regulations that were being debated needed to be enacted. Because what happened was the wood that made that trailer, wood that made the trailers were made incorrectly and giving off formaldehyde. And let me show you a couple of things. All right, everybody see Wikipedia, Hurricane Katrina, and it was caused 1,800 deaths, and it was in August of 2005. And it was a category and hit Texas, Louisiana, and thereabouts. Now, what FEMA had to do, and you should see FEMA trailers, and here they had about almost 150,000 trailers were bought. And it was quickly made by companies mainly in Indiana. And because of the hurricane, what they don't say in this part, but it's true, there was a shortage of wood, like plywood, used to make trailers in the United States. And where did they get new wood? From China. Now, what you don't know, and I do because I worked in the industry that makes the adhesive, the glue called the resin, to hold wood together to make plywood. The United States has OSHA, Occupation Safety Hazard Authorization Act, and that limits exposure to certain dangerous chemicals like formaldehyde. They don't have that in China. There's nothing wrong with China, but because of that, wood from China can be high in what's called free formaldehyde. And the wood that was probably used for those trailers were. If you notice down here, right here, they talk about health problems, and where it says in 2007 tests on a number of FEMA trailers by the Sierra Club, that was actually Becky Gillette, and she used her own money. And finally, Congress got involved, Henry Waxman. Now, why am I telling you this? Well, a couple of things. And one of the things Becky asked me to do when I've been helping her out with this was, could I call, or someone would call me, and could you talk to that person about formaldehyde and what you know and what you think has happened? I said, sure. Turned out to be the lead investigator for the Select Committee of Congress, which was then under the chairmanship of Henry Waxman, Congressman Waxman. I can't remember the gentleman's name. I talked to him about an hour, teaching him about formaldehyde and everything, because the committee was going to have a meeting or investigation. And just like they're doing now with what happened on January 6th, they were going to have a televised committee meeting and investigate those trailers. And Waxman was going to have the owners of those trailer companies come in before the committee, and it's going to be on TV. And they were going to show, look, we're all gung ho trying to get this problem. So I wanted to support him, and I taught this guy all about formaldehyde and everything. And near the end, I said, could I ask you a favor? I said, sure. I said, could you ask Congressman Waxman to ask the owners of the trailer companies one question? He said, what's that question? Ask them where they buy their wood for the trailers. And he said, I can't. He can't. And immediately I realized that was a show, what we call dog and pony show for TV, to show, oh, look, Congress is involved. They didn't want to get to the source of the problem. I think they knew it. And I've never proven it, but well, it turns out Becky was able to prevail. And then under Obama, we now have laws that regulate free formaldehyde in wood products, even though once in a while, be careful with Chinese products because they lie. And that happened a while, about 4 years ago, with lumber liquidator products that were coming from China. Why am I telling you this? Because I want you to see the following and know about the following. Becky has, I haven't talked to Becky in a couple of years because it's sort of wound down. She has her own website called toxictrailers.org. And here there's a picture of Becky right there. I've never met her face to face. I talked to her a number of times on the phone. Very amazing woman, brave woman. And right here, when FEMA said, you're not right, and Bush and the head of FEMA were telling the news Becky Gillette doesn't know what she's talking about, she was using the test kits from this company. And it's $39 a kit. I think it's still that number. And if you buy new cabinets that are not solid wood and they come from a Chinese supplier, if you have a newborn or know someone with a newborn, they go out and get new furniture for the bedroom. It's not made out of solid wood. If that came from China, which a lot of things do now, I would have it tested for formaldehyde. These kits work. The government proved this company was accurate. Use them. If ever you have a question about this, always feel free to call me. And over the years, I've had students use that company. I never have because I haven't bought any new furniture in many, many, many years. And when I did, it was before the knowledge that it was made in the United States, not China. But anyways, that's important for your health. One of the things Becky told me one story was she also dealt with other people who go out and actually go to your home personally and test for formaldehyde, but those kits work fine too. I heard the story about this very house, two stories. One was also in the LA Times that very wealthy individuals spent $50,000 on new cabinets in their kitchen and other things. And all of a sudden they're getting sick. Well, it turned out those cabinets came from China, and just like the trailers were emitting formaldehyde, getting them sick. Unfortunately, I had to have them ripped out and put ones that didn't do that in, and then they were fine. Now, another couple were very wealthy, or I don't know how wealthy, but one was an airline stewardess, the other was a hockey player with NHL, and they travel a lot. When they travel, they were all right. When they went back in their house, they got sick. And turned out it was furniture made in China that gave off formaldehyde that was making them sick. So that's an important thing to keep in mind. If you ever buy new furniture, ask where it's being made. If it's not solid wood, which most furniture has a thin layer of fancy veneer wood over particle board or oriented strand board, if it's coming from China, be careful. And if I look at the clock, I'm going to do something totally unusual. I'm going to let you out a whole 5 minutes early. I'll stick around if anybody has questions. And with that, tomorrow, excuse me, we'll do the review for test number 4. Make sure you do the problem set, or also for the organic chapter. I will go through that. I'll do the review for test number 4, and we'll do a lab. And with that, by the way, the lab is not on Beyond Lab Z. It's something I wrote. It's a lot of fun. So with that, I will say, Gang gesund. Goodbye.